Hello my dear students, welcome back to NEET World. So in this session we will be discussing few PYQs of physical chemistry part from NEET, JEE and EAPCET exams. Okay, so if you have followed this discussion from last few days, I have covered solutions, structure of atom as well as electrochemistry, redox reactions, thermodynamics. Okay, so all equilibrium, all this physical chemistry part is almost covered. Okay, let's see few questions from those discussion in this session, because once after completing every chapter or during the discussion of that chapter, I have covered related PYQs right now. So here here I have taken few more PYQs from those chapter. Let's do them. Okay, the first question here is from solutions chapter from EAPCET exam. The question says, what is the boiling point of solution of 0.1 molar KCl given Kb, that is elevation molar elevation constant as 0.52, alpha degree of dissociation is 100% for this KCl electrolyte. Now tell me what will be your answer for this question. Yeah, how can you solve this? See, elevation in boiling point now, so you can simply use the formula like delta TB is equals to I KBM right now. So what do we mean by delta TB? Elevation in boiling point. It means if T naught B is a boiling point of pure water. Let us say here we have a container in which water is present, only water is present. Okay, now we know boiling point of water is 100 degrees Celsius right now. So that is T naught B, I am indicating this is 100 degrees Celsius. Okay, right. To this water, let us add some solute like NaCl solute I am adding. What we are adding? Like KCl solute they have mentioned. Yeah, you can add KCl solute now. Now when you add this KCl solute, the boiling point of this solution, see, solute plus solvent becomes solution now, the boiling point of solution get elevated. It means previously it is boiling at 100 degrees. Now it will be boiled at little higher temperature, like let us consider 101 or 100 plus 0.5 or 102, like that. Depending on the quantity of KCl we are adding, its temperature elevates from 100 degrees to some higher level. Okay, so that is T naught B mine, like TSB. This is like boiling point of solution, this is boiling point of pure solvent, this is called elevation in boiling point, delta TB. Okay, which is equals to I KBM. So what is this I? I means Van de Graaff factor. See, when KCl undergoing dissociation, see, whenever I place this KCl salt in the water, what happens? It will get ionizes like K plus and Cl minus. How many ions we are getting? 2 now. So I value is 2. So you can take I value as 2 here. And what about Kb? So Kb here should be taken this one. So 0.52. Okay, what about M here? Molality is 0.1. That's it. So this is what you need to do. So this is 2 into 0.0. I mean, you can say it as 0.052. Okay, right. Now it can be 4. 104, it means 0.104. Okay, so this is TSB minus T naught B. See, if they ask what is the elevation in boiling point, this will be your answer. They are asking boiling point of solution means this TBS we need to find. Means you just send this that side, so it becomes 100 degrees. I can write 100 degrees in Celsius scale or 373 on Kelvin scale right now. So if you look at the options, all of them are in Kelvin scale. So instead of 100 you can write 373. So minus 373, if I send that side, it becomes plus 373 now. So 373 plus 0.104, you can write 373.104 Kelvin. So this is your final answer for the discussion. Okay, so where do we have out of these options, like 373.104 here? Yeah, so this is your perfect answer. See, if you look at the first option, they mentioned 100.104, but this is incorrect, because 100 degrees if you consider, you are going to get this is in degrees, this is in Kelvin. No, this is incorrect now. So perfect option is B. I hope this discussion is clear right now. Guys, if this is clear, please mention clear in the chat box. I am looking into it. If any confusions are there, please let me know in the chat box. Yeah, let's move forward. Now try to solve this question. What the question says, if 92 grams of sodium react with water in an open vessel at 300 Kelvin, what is the value of work done? See, from where this question is, this is from thermodynamics, right? So how can you solve this? 92 grams of sodium, it means sodium when reacting with water, what happens? We will get sodium hydroxide plus hydrogen gas. So if I take 1 mole of sodium, 1 mole of water, it will reacting, let us say, so it will be forming half mole of H2 gas. Okay, this is as per the balanced equation now. Okay, now how many grams they have given? Previously as per equation 1 mole, they mentioned it as 92 grams. 92 grams divided by atomic weight of sodium is 23. So this is 23 gram per mole. Okay, you are going to get these as a 4 right now. So 4 is a 12, 4 is a 8, 9, 92. Okay, so now 4 gram, like 4 moles we got. Okay, so if it is 1 mole of sodium, you are going to get half mole of H2, right? So if it is 4 moles, it should be half of it. So 2 mole of H2 is produced here. So up to here it is clear. Now they are asking what is the value of work done. So how can you calculate work done? See, work done is equals to minus external pressure into dV we need to take. Okay, so P dV you can write. Simply you can write W or dW is equals to minus P dV we can write. But did they mention anything about pressure? No. Anything about volume? No. So we have ideal gas equation here. PV equals to nRT, right? So if there is any change in pressure, that means delta PV if I write, that is also can be written as delta Ng RT. So what is this delta Ng? See, ideal gas equation, it is applicable for gases only. So gases means here number of moles of gas only, not this one. So there is change in number of moles of gas you can take. So wherever I have change in PV, there I can write in delta Ng RT also. This is minus delta Ng RT. Okay, right. If you look at the given equation, sodium is a solid, water is liquid form. Okay, and here aqueous medium, this is also liquid form. So only product is in H2 is in gaseous form. Now as per the data provided, how many moles of H2 is produced? 2 moles now. So number of moles of products are 2 minus number of moles of reactants are 0 because no gaseous reactants are there. So here you can write minus 2 RT. So they are asking answer in terms of joules. So R can be taken as 8.3 joules here. Okay, joule, Kelvin inverse, mole inverse, you can take as a units. And the next, what about temperature here? 300. Okay, 300, that's it. Okay, right. So now upon simplifying this, what you are going to get? So you are going to get it as minus 4988. Almost this is the answer you are going to get for this simplification. Okay, hope this is also clear. Guys, if this is clear, please mention clear in the chat box. I am looking into it. Yeah, right. Let's move forward. Or hit on the like button based on your understanding. If it is clear, please hit on the like button. Right. Next question here. If the osmotic pressure of cane sugar is 2.46 atm at 27 degrees Celsius, then what is the concentration of the solution is? Okay. So how can you take this? Osmotic pressure pi is equals to molar concentration into universal gas constant, or you can say simply S T. And if there is any electrolyte, you can say I value. Insertion of I value is very important. See, cane sugar, it's a non-electrolyte, its I value is 1, and they are asking molar concentration. This is Cm, means molar concentration, that is nothing but molarity. Okay, and here pi mentioned as osmotic pressure 2.46 atm, right? And what about this side? S as 0.082 liter atm. Okay, and temperature as 27 degrees. Now take it in 300 Kelvin. Okay, liter atm, Kelvin inverse, mole inverse, you can remove this Kelvin there. Okay, so here atm pressure is removed. So here 1 molar is there. So now we'll get this value as 2.46 by, so 300 is there now, so you can write this as 8.2. So 8.2 3s are Okay, so this is almost 624. Okay, so 24.6. So this is how many times? 10 times right now. So this is 0.1 molar. So what is the concentration here? 0.1 molar. That is option number 1 is perfect for this discussion. Okay, is this clear, guys? Yeah, let's move forward if it is clear. Yeah, the next question here related to RLVP. So how can you do this? Tell me. Relative lowering of vapor pressure. What is the formula for relative lowering of vapor pressure? So it is P naught minus PS by P naught is equals to mole fraction of that solute. It means, what do we mean by mole fraction of that solute? See here, 6 grams of non-volatile solute is taken. So here what do we mean by mole fraction of solute? That is number of moles of solute by total number of moles, that is number of moles of solute plus solvent you need to take. Okay, so here number of moles of solute is nothing but given weight of solute by molar mass of that solute. See, they mentioned 6 grams of solute, it means weight is mentioned. Okay, dissolved in 100 grams of water. So number of moles of solvent, how can you find this? Weight of solvent by total like molar mass of the solvent. Molar mass of solvent is 18 and number of moles of solute is 100, weight of solute is 100. Okay, that's it. The relative lowering of vapor pressure of resultant solution is, so this relative lowering, it means RLVP, this value is given as 6 into 10 power minus 3. That's it now. So you just substitute that by simplifying that, you just put over here NB by Na plus NB. Okay, so that's it. NB value you get from here means 6 grams by molar mass you can calculate as it is. Okay, you put over here and this one in the denominator, multiply with this, you will get one of this option. Please mention based on simplification, you mention what's your answer for this discussion. If not, I have discussed this kind of model questions in solutions chapter, you can watch it once. Okay, right, let's move forward. What about this? Heat of formations of 4 substances are given. These are the 4 substances given in kilojoule per mole. Now they are asking enthalpy of reaction for this. See, this is a chemical reaction they mentioned. Heat of formations for them it is mentioned. So how can you calculate this? Again I will tell you, follow this step. So enthalpy of reaction they are asking now. What is the data provided? Enthalpy of formation, standard enthalpy of formation. So what are the species forming out of this 4? You take them as formation like products. These are NO2, N2O and CO2 are the products. So whenever heat of formation is given, take in summation of enthalpy of formation of products minus summation of enthalpy of formation of reactants. Okay, reactants. So when to use this? Whenever formation is given, enthalpy, standard enthalpy of formation is given, use this formula. If standard enthalpy of combustion is given, you take enthalpy of combustion of reactants minus products, because here what are the things forming? These products are forming now, so that's why you take the values of products first, and these are deforming, but the given formation values, but these are like reactants are deforming, like undergoing decomposition or deformation right now. So that's why this negative symbol is used here. Okay, that's it. Okay, now write the values here. What are the products here? N2O. Enthalpy of N2O is how much? Only one N2O is formed. So it's a third value, that is 81. Okay, plus what about CO2? Here 3 moles is forming now, 3 into here minus 393 for CO2, like 393, there it is minus symbol. Okay, minus of, okay, and here reactants. What are the reaction? NO2 is there. How many are there? 2 NO2s are there. 2 into, okay, NO2, last value here, that is 34. Okay, right, plus one more is 3 CO. So 3 into CO, second value, that is minus 110. Okay, so right. So upon simplifying this, you are going to get the answer as minus 836. You just simplify this, you will get enthalpy of reaction as minus 836 kilojoule per mole or kilojoule per the substance. Okay, right. This is the answer for the discussion. Okay, I hope you got how to simplify this kind of questions like enthalpy of formations. If mentioned, this is the scenario. Now enthalpy of combustions are mentioned. You take this as a first value, that is enthalpy of reactants minus enthalpy of products. Okay, that's it. Okay, now look at this question from electrochemistry. Once read the question, what it is saying. What it is saying, once read it. For a cell involving one electron, what they are saying? For a cell involving one electron, number of electrons involved are 1. Okay, and its standard electrode potential is 0.59 volt. Okay, at 298 Kelvin, the equilibrium constant for the cell reaction is, they are asking K equilibrium, how much? Okay, now what the equation that relates electrode potential with equilibrium constant? We have one equation now, the standard Gibbs free energy delta G naught is equals to, that is also considered maximum work done, is equals to minus like charge into potential, charge into potential, here charge as NF, okay, NF into E naught cell. Okay, so what is this E naught cell? This is potential, this is charge. So F indicates number of Faradays and N indicates number of electrons involved. Okay, this is Faradays, this is number of electrons involved. Okay, since they are saying it is 1 electron, you can say minus 1F E naught cell also. This is fine up to here, and they need to relate that with equilibrium constant. We have one more equation, that is delta G is not equals to minus 2.303 RT log K. Okay, this is equation 1 and equation 2. Both of them are equal to delta G naught only now. So let us make it as minus NF E naught cell is equals to 2.303 RT log Kc. Actually you can get it from Nernst equation from there itself. Anyways, everything is from the same point of view, from here itself. Okay, so here what I am doing, you just check, they have mentioned a value here, 2.303 RT by F as this much. Okay, so here I am writing E naught cell is equals to minus can remove both sides, E naught cell is equals to 2.303 RT by NF is there. Okay, log Kc. Okay, right. From here you can see what is the E naught cell value mentioned, this is 0.59. And what about this whole simplified value, they have mentioned it as, this answer as 0.059 by N. So number of electrons are only 1 now, so N equals to 1 in the denominator, log Kc. Okay, so this is bigger value now, how many times bigger? 10 times. Okay, so we got log Kc as 10. So from here Kc equilibrium constant is equals to log, if I send this side, becomes base 10 to the power 10. Okay, so what is our answer here? Kc is equals to 10 to the power 10. So here we have option C as 1 into 10 power 10. So that is your answer for the discussion. See, the questions here we are discussing are from NEET or EAPCET exams. Okay, right. If this is clear, let's move forward. Yeah, and if you are not clear about electrochemistry, you can watch my previous sessions that I have made for electrochemistry. Even more number of questions are solved from each chapter whenever I discussed that particular chapter. Okay, at the end of the chapter or during the chapter I have discussed the questions. Now look at this question. The question says, consider the change in oxidation states of bromine in corresponding to different EMF values as shown in the diagram below. Then the species undergoing disproportionation reaction. Okay, so I will tell you one simple tricky way to solve this type of questions. See, whenever they have given a series of reaction like this, now if they are asking about disproportionation reaction, you just calculate E naught front minus E naught back, front minus back. If this value is positive, then that species will undergo disproportionation reaction. See, for example, let us consider this one, bromate ion BrO3 minus is there. Front minus back, if you do, this front value is smaller, then the back value. So it is a negative. So it won't undergo disproportionation here. Okay, right. So in the same way, if we consider for this, HBRO is there. Front value is 1.595 is there. Here 1.50 is there. Front value is higher now. Yeah, front minus back. You are going to get some positive value here. So it means HBRO will undergo disproportionation reaction. Okay, it means C option is perfectly correct, and you can verify for BR2 also. See, front minus back. See, front value is smaller, smaller minus bigger means negative, definitely. Okay, so this won't undergo disproportionation. Only option 3 is your perfect answer for this discussion. Okay, is this clear, guys? This is one of the very simple trick to calculate or to identify disproportionation reaction in a series of reactions for a particular substance. Okay, right. Let's move forward. Next, tell me for this, what is your answer from Cool-Rush law? Which of the following expressions correctly represents the equivalent conductance at infinite dilution of Al2 SO4 tries? So it is going to give you Al3 plus 3 SO4 minus 2. Okay, given that like limiting molar conductance of aluminium SO4 minus are the equivalent conductances at infinite dilution. See, whenever they mention the conductivity values of that ions also in equivalent conductance, you just take them as ions like this. Del naught of Al2 SO4 tries we need to calculate right now. So whenever they mention equivalent conductance in the question, you directly mention that as the answers here. So del naught of Al plus 3 plus del naught of or ionic conductance of Al plus 3 and ionic conductance of sulfate ion. That's it. This is your answer. But if they given this is for equivalent conductance, okay. But if they mention about a molar conductances, del m of Al2 SO4 tries, by giving their ions also, ionic equivalence conductance also, ionic conductance also in molar conductance, you need to multiply number of those ions. So 2 ions are there now, 2 into del naught of Al plus 3 plus sulfate ions are 3 del naught of SO4 2 minus, like this. Okay, this is a small difference you need to remember here. Okay, right, let's move forward. So as per the question, what is your answer? So option B is your answer, because they are asking about equivalent conductance for that electrolytic solution. Okay, right. Next, look at the question. Half-life of a first order reaction is this many seconds. The specific rate constant of the reaction is, so specific rate constants means K. Okay, so what is its K? So we have an equation like K is equals to 0.693 by T half. Okay, this is what T half formula now. So that's it. Half-life of a first order reaction is this much, then specific rate constant. So from using like a T half of first order, we can calculate this K, specific rate constant. So you can say 0.693 T half. How much they mentioned? 1386 seconds. Okay, so now this value I can write a 10 power minus 3. So 693 2s are, we will get 1386. Okay, so it means 1 by 2 means 0.5 into 10 power minus 3 second inverse. Okay, do we have any option? 0.5 into 10 power minus 3 second inverse. So option B is your answer for the discussion. Okay, right. Now sometimes they will provide the information about half-life, rate constant in this way, and they will ask what is the time required for completion of some y% or x%, like that also they may ask. So it means you can use T x% by T y% as log 100 initially, x% completion now 100 minus x. Okay, and here log 100 by 100 minus y. Okay, like this. This is the formula to compare two half-lives or two x and y percentages. For example, I am asking you to calculate t 50%, t 75%. What is the relation here I am asking? So x value here is how much? Let us say t x I am saying 50%. Here I am saying t 75%. So what is the relation here we got? Log 100 by 100 minus x, 100 minus 50. Okay, log 100 by 100 minus y, that is 100 minus 75, that is 25 here. That's it, we are done with this. So log 2 here, so this is log 4 here. So finally what we got? T 50% by T 75% is equals to log 2 by 2 log, log 4 is there now, so I can write 2 log 2 also I can write, because log 4 means 2 square we can write. So log 2 is removed. So you can simply relate T 75% is equals to 2 times of T 50%, that's it. So this is the way you can do it for first order reactions. Okay, not only T 75, T 50, you can take any percentage, T x percent, T y percent. That's why I generalized it as T x by percent by T y percent. Okay, this is one of the very useful equation. Okay, right. Let's move forward. Yeah, it's perfectly correct. Yeah, look at this question again. This is also PYQ question. The question says the unit of rate constants for a zero order reaction. See, I will give you one generalized way to calculate rate constant values. So how can you do this? Constant, rate constant for any order, rate constant units you can take like this. Take concentration to the power 1 minus n into time inverse. Okay, this time inverse is same for everything. So what do we mean by concentration? Generally concentration is expressed in terms of molarity, right now. So 1 minus n time inverse. So now molarity means what? Molarity means what? Mole per liter, right now. So you can write here mole per liter 1 minus n time inverse. Okay, since they are asking for zero order, so n can be 0 now. If n is 0, so what happens? It is mole per liter 1 minus 0 into time inverse. So this simply becomes mole liter inverse time inverse. So this is the units for zero order reaction. For which one? Zero order reaction. Can you tell me what are the units? What are the units for first order and second order equations? I mean second order rate constant. Okay, so units for first and second order, I want these answers in the chat box. Whoever watching live, or you can watch it after recorded version also, please let me know your answers for first order, second order rate constant units. Okay, right. Next, let's move forward. Let's move forward with few more questions. Yeah, look at this one more question from chemical kinetics. What this question says? Yeah, question says that in a reaction A plus B gives rise to product. The rate is doubled when concentration of B is also doubled. It means it's very simple, ma. I will tell you one tricky way to solve this. You use this. So 8 power rate of a reaction depends on concentration of reactants only, right? Concentration of B and concentration of A, and there will be orders with respect to each reactant and reactants involved here. So A power m, B power n. M is a order with respect to A, n is a order with respect to B. Okay. Now what they are saying, rate is doubled when concentration of B is doubled. So rate becomes 2 times when concentration of when concentration of B is double, it means concentration of A might be remained constant, only B is changed. So when concentration of B is becoming 2 times double, rate is also doubled. So now look at this, by comparison of these, you can get, here we have 2, here also we have 2 power n, remaining R and B as it is. Okay, so now 2 power 2, so what is the n value here I can put, so both values becomes equal here. Okay, so 2 power 1 is equals to 2 power n. So now here n equals to 1, you can simply write in this way. So order with respect to B is 1. Now read the complete question. And rate increases by a factor of 8. It means rate becoming 8R. Okay, when concentration of both reactants A and B are doubled. It means this is becoming 2A to the power m, and this is also becoming 2B to the power n. So what is the n value here we got? It is 1. Okay, that's it. So here I can say 8 is equals to 2 power m, and from here 2 power 1. So I can write 8 as 2 power 3 right now. So now 3 is equals to m plus 1 we can write now. So m can be now 3 minus 1. So it is how much? 2. So got it. So order with respect to A is 2, order with respect to B is 1. So finally what we got? There is K constant, A power 2, B power 1. That's it. This is your final relation. So where do we have this kind of option? A power 2, B power 1. So first option is your perfect answer for our discussion. Okay, guys, is this clear? Guys, is this clear, whatever we have discussed? Right, let's move forward. Look at this question. The question says, if the radius of second Bohr orbit of helium ion is 105.8 picometers, then the radius of third Bohr orbit of lithium ion is, lithium plus 2 ion is. See, what is the formula for lithium or helium ions? See, these are Bohr model questions now. So Bohr model applicable only for single electron species. Like radius of an nth orbit is directly proportional to n square by z, we can say. Okay, right now. So here radius of second Bohr orbit of helium plus by radius of third Bohr orbit of lithium plus 2 is equals to, here n square, what is the n value here? 2, second Bohr orbit na 2 square 4 by helium atomic number 2 square is 4, helium atomic number is 2, so you can write here 2. And what about lithium? Z n square, here also n square, 3 square 9, and its atomic number is 3. Okay, so finally what we got? Here it is 2 times, here it is 3 times. We got 2 by 1. Okay, this is 3 by 1. So here it is 3 into 1. Okay, you got 2 by 3 as your final relation. From this, they are asking, what is the radius of third Bohr orbit of lithium if helium is that much? Helium is 105.8. Okay, you just send this 3 here into 3 divide by 2 is equals to R3 of Li plus 2. That's it. Do you got what I am doing here? So just multiplication here properly. Okay, so this will be 5 times. This will be 2 to the 4. Here 1 is there, 0.9. Okay, that's it. Upon multiplication here, 27, 2, 6, 7, 8, 15. Okay, so 158.7. So 158.7 picometers. Okay, so option B is your perfect for this discussion. Okay, guys, is this clear what we did? I hope I mentioned each and every step very clearly. one more question here from the structure of atom itself. The question says, once read the question. The question says the energy of an electron in the ground state for helium ion is minus x joules. Then that for an electron in n equals to 2 state for beryllium ion will be. Okay. So what is the formula we have here? Energy of an electron in nth orbit is equals to minus 13.6 z square by n square electron volt per atom is there now. So from here also you can relate like energies like proportional to minus z square by n square, that's it. So from here you can get one of these answers. See, once read energy of electron in the ground state of helium. So E1 of helium ion is equals to minus z square. Z square is how much? Atomic number. So 2 now, 2 square 4 by ground state n equals to 1 here. Okay, and energy of, and that for electron in the second of beryllium plus 3. So here also minus, what you can say, it's a ratio now, you can take in this way. So z square 4 square 16 here, and n is 2 square 4. Okay, so it will be 4 times now, minus is removed. So you got 4 by 1 to again 4 by 1. So it is same. Okay, we got 1. So it means energy of first state, ground state of helium ion will be equals to energy of first excited state or second level of helium ion. That's it. That's it now. So this is perfect. So what is the value? Whatever you have seen for energy for helium ion, same will be there for beryllium plus 3 ion also. Okay, beryllium plus 3 ion also. Okay, beryllium plus 3 ion also. So what is that answer? So it is minus x. Here also it should be minus x. Okay, so option C is your answer for the discussion. Right. Right. Let's move. Yeah. So now I will give you few more questions from the previous discussion here. Yeah. So like look at this question. What's your answers for this thermodynamics questions? Read the question once. In an isothermal expansion of 1 mole of ideal gas against vacuum from 5 liters to 50 liters at 300 Kelvin, the quantity of heat absorbed will be. See, they are saying isothermal expansion. It means temperature is constant, change in temperature is 0. Similarly, if temperature is constant, internal energy also constant right now. So therefore change in internal energy also 0. Okay, during isothermal process, internal energy will be 0. You can remember this. Okay, and in change in internal energy will be 0. So now from first law of thermodynamics, you can write du equals to dq plus dw. See, if du is equals to 0, then it becomes dq plus dw. So dq is equals to minus dw. Okay, so now whatever the value you are getting for work done, same value is there for your heat absorbed also, okay, right. So now here dq is equals to minus dw we got. dw is nothing but work done now. So what you can see, dw equals to minus external pressure P external dV. Okay, so now look at this, volume is changing from 50 to 5, that is 5 to 50, that is fine. But what about external pressure? See, against a vacuum now. So vacuum means, is there any pressure? No. So external pressure is 0. So if external pressure is 0, 0 into something 0. So the work done here is 0. If this value is 0, then dq also 0. So what is your answer for this discussion? A. So this is your answer for the discussion. Okay. So after, can you discuss JEE Mains 2026 papers, sir, please? Yeah. See, soon I will be starting each and every question that I am going to start the discussion of each and every question of JEE Mains phase 1 papers. Okay, particularly chemistry here. I will be discussing them in next upcoming live sessions. You just stay connected with us. Definitely I am going to make videos on it. Okay, very clearly we will discuss each and every question. Okay, next, what about 102 question? Tell me. This is also one important model question, 102. How can you do that? The dissociation energies of H2O2 are given this much. Then the heat of reaction is 10 kilocalories. Okay, then bond energy of OH bond is. Okay, how do you do this? See, bond energy means what? The amount of energy required to break this bond, right now, required to break this type of bonds. Okay, right. So now, this is nothing like bond energy is given. So, amount of energy required to break something like whenever they mention bond dissociation energies or bond energies, it means they are given for like reactant side bond is breaking now. So, it means you need to take enthalpy of reaction as enthalpy change in reactants, summation of enthalpy of reactants minus summation of enthalpies of products, or I can simply say bond energies of reactants minus bond energies of products. Okay, right. Now based on this, you tell me what we can do. Here reactants, what are the reactants they have given? Half HH, like H2 is given, HH here, right, plus this is also half O2, OO, okay, minus this OH is forming now. How many? One OH is forming, one OH, okay, that's it. So you put the values over here. What is the enthalpy of reaction? They mentioned 10 kilocalories, 10, okay, and for H2 it is 104, okay, this is 10, 1 by 2 into 104 plus 1 by 2 into 118 minus OH. This OH bond energy they are asking. So it's simple. So you can get 52. This is 9. Okay, 59. Yeah, you can send that this side. So you are going to get the OH bond energy as this is 111. So 111, if you send this, it becomes 101. So 101 kilocalorie is your answer for this discussion. Okay, where do we have 101? Yeah, first option is your answer for the discussion. Okay, is this clear or not? I hope this is clear. Discussion is clear. The next question here, again from thermodynamics, here we have enthalpy and entropy for the reactions are given like this, minus 50 and minus 20 this is kilojoules, this is normal joules, okay, respectively. Now what is the highest temperature up to which the reaction is feasible? So how can you say a reaction is feasible or not? It's very simple now. You can do it by just taking Gibbs free energy, delta G equals to delta H minus T delta S. This is the equation to be considered over here. Okay, so for a spontaneous or a feasible reaction, delta G has to be negative. In order to making it negative, you need to compare this delta H and delta S values. This is the first term, this is the second term. Okay, the first term here mentioned as minus 50 kilojoules. See, kilojoules now I am writing 10 power 3 joules because entropy is given in joules, that's why. And this one as minus 20 joules, 20 joules. See, see what they have mentioned, this is minus of T and this is minus 20. See, in order to make delta G negative, overall term should be negative. See, first term is negative, second term becoming positive because negative into negative becomes positive now. So, which term should dominate here? The first term has to dominate here. So, you need to calculate or you need to make the delta H should be, delta H should dominating then this delta S. It means delta H by delta S should greater than T here. Okay, then only reaction is spontaneous, then only delta G becomes negative and reaction will be spontaneous. Okay, so this is 50, so here minus 50 kilojoules, that is 10 power 3, 1000 or 10 power 3 joules, and in the denominator delta S is minus 20 joule per Kelvin is mentioned. So minus, okay, so joule. So your answer is going to be in Kelvin now. Okay, so this will be 0 cancelled. Okay, so this is 5. So you can get this as, this is not 50, this is just a 5. Okay, 5.0 this is. Okay, so now you can get this 10 power 2, this is 500 by 2. So you got temperature this value as this term as 500 by 2, it means 250 right now. So temperature if greater than T, then reaction is, then what happens? A reaction will be spontaneous. What happens? Reaction will be spontaneous. Now what they are asking? The highest temperature reaction which is spontaneous. Yeah. So the highest temperature is how much? 250 here. Okay. That's it. So here you have option B. Okay. So if this temperature value becoming now 251, what happens? If this temperature, if we maintain greater than 250, then the second term will dominate. Therefore, second term is dominating means it becoming a positive value. If it is becoming positive, delta G becoming positive value means it is a non-spontaneous process. Okay. So what is the maximum temperature we can maintain? 250. If you maintain more than that, it becomes a non-spontaneous process. So below that, it will be spontaneous. So option A is your perfect answer for the discussion. Okay. Now at 240 degrees, it is spontaneous, 250 also, and but if it is 275, 300, then here it is a non-spontaneous reaction. Non-spontaneous reaction. Okay. Hope the complete discussion is clear. Right. The remaining questions, I mean, there are few more chapters to be completely covered here, I mean in this PYQ discussion. Let us do them in the upcoming sessions. Okay. So till then you just stay in connected with this channel, and if you have any doubts, please write in the chat box. Okay. In the upcoming sessions, as I mentioned, I am going to cover JEE Mains Phase 1 chemistry part, okay, from all the sessions. Okay. You just stay connected with us. That will be highly useful if you are preparing for upcoming JEE exam as well as NEET exam also, because in the NEET exam also level of questions were really raised to a good level. So you need to do questions from JEE also in the practice sessions. Okay. So thanks for watching. Stay connected.